So 3 different reactions are given, and with the help of that one, we need to find out the enthalpy of formation of the liquid water. So what is given in reaction 1? It is formation of water given, and it is from 1 mole of H plus ions and 1 mole of OH minus ions. And in the second equation, it is given that 1 mole of liquid water is formed from 1 mole of hydrogen and half mole of oxygen. And in the third one, here also 1 mole of H2O is formed along with 1 mole of CO2 by the reaction between 1 mole of CO2 and 1 mole of hydrogen. So in all the cases, 1 mole of water is formed, but the enthalpy change is different. And this we can answer only based on recollecting the definition of enthalpy of formation. So what is enthalpy of formation? It is the enthalpy change involved during the formation of 1 mole of water from its constituent elements. Means 1 mole of water need to be formed in its standard state from 1 mole of hydrogen from its standard state and half mole of oxygen which is again in its standard state. So what is the enthalpy change involved in this particular process? That is called as the enthalpy of formation of water. And in the given reaction 2, we have the similar equation, isn't it? But the only difference is the energy change is given along with the product side, which indicates that this reaction is an exothermic reaction, isn't it? According to thermochemical equation, we need to represent this enthalpy change as a separate value in terms of delta H. So now we can write the delta H value as equal to minus x2 kilojoules per mole, isn't it? That's the reason why our answer is option A. I repeat here, it is a formation of 1 mole of liquid water from its constituent elements. And as during the formation of 1 mole of liquid water from its constituent elements, the energy released is equal to x2 kilojoules per mole, the enthalpy change for exothermic reactions is negative. So our answer is minus x2 kilojoules per mole. It is not positive value. Because as per the thermodynamics, we need to express the amount of heat released or absorbed in a chemical reaction in terms of delta H. And for exothermic reactions, we know that delta H is always a negative value.